Jared. Do you want to do the intro this time?
Hi, everybody. Welcome to Rule Your Pool podcast. This is Jared here with my co host or sometimes host, Eric Knight. Eric, nice to have you here today.
Oh, it is great to be back. Thank you for having me, Jared.
This is two in a row for me. I might as well
No,
be a regular now.
no. This is three in a row.
Oh, so much fun. I forgot.
Not only can you not read, you can't count. But that's
Mm.
okay. That's separate. This guy does the accounting for our company, by the way.
Oh, man, we're having so much fun here. It's summertime in the pool business. Everybody's just listening to our podcast, all 11 people now.
Yeah.
Um,
And recently, we became the 17th most popular swimming pool podcast, which is great. We finally got into that top 17. So thank you all to the listeners. We're really grateful for all of that. What are we covering in today's episode, Jared?
well, everybody, today we are going to cover different types of phosphates because they are in our water all around us.
That's
So
right.
let's get into it.
Here we go, episode 71.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Now, Jared, we could go down this rabbit hole of all the different types of phosphates that could be in your water. And there's, classifications and then groups within those classifications, and it would just take forever. What I really want to start with is, what is an orthophosphate? PO4. An orthophosphate is what test kits measure. That is the base unit of phosphate compounds that you're going to find in your water. And there might be some others, but we're simplifying here for the purpose of the podcast. Basically, any phosphate compound is going to have building blocks called orthophosphates. No matter what form you have in there, with enough time, presence of sunlight, presence of oxidizers, those compounds will break down into orthophosphates eventually. Most of them will, at least the ones that we deal with in swimming pools. So when you put in a sequestering agent, for example, which is phosphonic or phosphoric acid, depending on what you have, that has orthophosphates in it as building blocks, but it's not going to present itself on an orthophosphate test. Now, you did this yourself.
Yet.
That's what I mean. You did this yourself where you tested low phosphates, then you took that sample in the bottle, you left it out in the sun for a while, and you tested it, and the phosphates were high, right?
Correct.
That's because over time, it will break down into those building blocks of orthophosphates, and that's what you can test for. Most test kits only measure those building blocks. And I mean, some, I guess, can do total phosphates, but I've never seen one of those kits. Part of the reason that it's hard to do is because there's so many variations. I mean, I link in the blog to a page that has like 30 different types of polyphosphates. We're going to break into some categories just to give you a feeling for how many there are, even though we're not going to get into it all. There's really two categories of phosphates. There's organic phosphates, also called organophosphates, and there's inorganic. Now, most of what we deal with in swimming pools is going to be inorganic, meaning they're not carbon-based. The organic ones come from decaying living organisms, meaning dead leaves, grass clippings, soils, that kind of thing. Things that were organic but contain phosphorus, plant life. Those things will contain organic phosphates. But again, percentage-wise of what we deal with in pools, it's really not that much. So most of what we're going to focus on is inorganic. Inside the inorganic category, of course, you have the orthophosphates, like you do in everything else, but you also have what are called condensed phosphates. That's another word for compound, phosphate compound, basically. Condensed phosphates, we have a nice little graphic on the blog, are primarily into two different categories. You can have polyphosphates, which are a bunch of orthophosphates chained together by common oxygens. Or you can have metaphosphates, which instead of a chain is going to be a ring, still combined by mutual oxygens, but
I would give everybody a graphic here. They look like honeycombs. A metaphosphate looks like a honeycomb, where a polyphosphate just looks like a chain link straight line.
yeah, one is a chain, that's the polyphos, and one is a ring, which is the metaphos. So if you have these products in your pool, like sequestering agents, again, phosphoric acid, all right, that's going to be a polyphosphate in most cases. There are some products that might be a metaphosphate. Your test kit will not pick those up until they break down into orthophosphate. So that gets to the question that we often get, Jared. If people use PR10,000 and it clouds, you are seeing it do its job. You are removing phosphates.
You are seeing a reaction in the water. It is reacting, period.
We don't know what it's reacting with. So you may not have a phosphate level of orthophosphate that goes down as much as it should have because there are other forms of phosphate in your water. That's basically what it comes down to. So this is where the confusion kind of comes in. You don't need to remember all the different types. Just understand that eventually all these other forms are going to break down to their building blocks. It just takes time. Anything you want to add on that right now?
Yeah, I want to get into the fact that we get the calls, and if somebody's prescribing the X amount of product to remove X amount of phosphates, it's, well, I added it, but it only went down 100, or it didn't go down at all. And a couple of questions that I ask are, number one, what is the max level your test kit goes to? Because there are limitations on how high we can test before this variance gets into play, or because the higher you go, the more variance you're going to get. So a lot of the times it's 1,000 parts per billion, everybody, or 2,500 parts per billion. Now, orthophosphorus is measured in parts per billion, not parts per million, like your chlorine, your alkalinity. All the other things that we test for are measured in parts per million. The test kit only went up so high. You're trying to decipher something that is a very small unit of measurement. It's not that accurate, I'm sorry. When people call and say, well, I have 500, do you? Probably not.
Yeah, 500 or less is our third pillar of proactive pool care because that's what the research shared to us by Richard Falk has said. Under 500 is going to be beneficial for chlorine efficiency. And you could go check out pillar 3 all you want. But measuring exactly 500, like Jared said, it is kind of tough. So if you want to know a foolproof way of knowing if phosphates are present, just do the cap test. Well, we can't tell you how much that is, but if they're in there, it will react, and you'll see that cloud.
And I like telling people, too, it's the speed of the reaction, too. The more phosphorus you have in your water, the faster it's going to present itself. If you listen to our previous episode, everybody, the colder the water will slow this reaction down. The hotter the water will speed this reaction up. Same thing here. If the more phosphorus you have in your water and the warmer the water is, the faster that will present. The colder your water, the lower the phosphate level, the slower it will present. It's not a slam dunk way of saying I'm high or low, but it gives you a general idea of kind of the path you need to follow.
Right. So if we could summarize here, and let's back up. The main reason we're even doing this episode is because of the sheer volume of calls of people asking about PR10,000 and why the levels are doing what they're doing. Some love it. It just wipes everything out. Some are like, well, gosh, it just didn't reduce as much, but it clouded up my pool like crazy. So I know it did something. That's why. There are other forms that your test kit couldn't do. So it's just like a miscommunication between the test kit and the actual product. That's what we're getting at. We're going to leave it as simple as that for now. If you want to dive deeper into the chemistry, feel free. We did a ton of research on this, and I mean a ton of research. Get onto the NIH website. You can get into ResearchGate, ScienceDirect.com. I mean, you could just find a ton of information about how phosphorus interacts with water and other chemicals. We're not going to get into that here.
We're not, but our ultimate goal here is to promote proactive pool care with no chemical conflicts and long-term byproducts, right? That's our deal. Well, if you are going to control phosphates, everybody, you need to understand that if you have a chemical conflict, as in adding a phosphate-based sequestering agent, which there are a lot of those in our industry, you got to be prepared for that and make sure you're not doing something detrimental that maybe your service guy or you as the homeowner were trying to combat, whether it be scale formation or a metal in the water and you want to get rid of it. Well, if you add a phosphate remover, you're going to negate that and it's going to be counterproductive. So be prepared. A lot of times we get these calls with pools in areas where they close pools, and a lot of pools are closed with a phosphate-based sequestering agent. So when they go back into opening the pools in the spring and they're trying to do their maintenance and they're in, let's say, May, and they're checking phosphate levels and they're through the roof. Well,
right.
That's because we did it to ourselves, and we added a product that did it on purpose because it was serving a purpose, but now we have to manage the baggage. And Same thing with the tap water coming in to fill these pools up when you're starting them up or the evaporation is occurring. The phosphorus levels are increasing as we're adding more water from the municipal water districts. So
Right.
this happens, everybody. Just prepare accordingly. Understand that your test kit has limitations. Don't shoot yourself in the foot by creating another problem you weren't anticipating.
Yeah, and actually on that note, because this is not in the show notes, you bring up something good about drinking water. One of the big questions that we get is like, why phosphates were never like a big issue? Why are they such a big deal now? Well, it's because they're in the drinking water now. Go back 15, 20 years, most drinking water facilities didn't add phosphates to their drinking water. At least it wasn't very common. Now it's in almost every place that you have city-treated drinking water. That's to protect us. It's to protect the infrastructure, or to sequester metals, or to prevent corrosion, or whatever it is. Phosphates themselves are healthy for us. They're essential to every cell in our body. So having them in the drinking water is actually a really good thing. It's just really annoying for swimming pools.
Well, that's what I was going to say is they serve a good purpose in the municipal water district's pipes because they give protection to the infrastructure. And I was going to ask, are they harmful to us? Because I've received calls, well, my phosphate levels are through the roof. Is that harmful?
No, not at all. They're actually very healthy.
They just create inefficiencies for our chemicals we are trying to manage. That is what this comes down to, everybody.
That's right, because chlorine cannot oxidize phosphates. You need an actual phosphate remover. They don't interact directly. It's an indirect relationship. Look at Pillar 3. You can take 4 Pillars Academy. Just go on our site, search Pillar 3. You'll find it. Plenty more information there. We're not going to go down that path right now in this episode, but we appreciate you taking the time and spending that time with us. I am your, I guess, co-host, Eric, and I'm sorry, I don't want to take your thunder. Jared, I'm sorry.
I was about to say, buddy, this is my exit.
3 in a row for you. This is a record. I'll let you close us out, please.
I want to thank everybody for joining us today, and I want to thank Eric for being on the podcast. If you have any other comments or questions, please visit our website, go to our app, shoot us an email on what you want to hear, or if you have a question. We'd be happy to help out, and thank you for your time.
Jared, I think you're getting too good at this. Thanks, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.